Alright folks, let's do number 36 here. In an assembly operation illustrated in the figure P3.36, a robot moves an object first straight forward and then also to the east around an arc forming 1/4 of a circle of the radius 4.80 centimeters that lies in the east and west vertical plane. So, well, I'm going to redraw this, but let me finish reading. The robot then moves to the object forward to the north through 1/4 of a circle of the radius 3 point that lies in the north and south vertical plane. Find the magnitude and the total displacement of the object, the angle. What the fuck? Wait, what? The magnitude and the total displacement of the object. Oh no, of the total. Oh my god, I'm misreading it. The angle, the total displacement mixed with the vertical. I'm not sure what they mean by vertical, but I'm going to give it a shot. I'm going to pull the solution manual either way. But luckily, I do know how to solve this. I just don't know what they mean by the angle with the vertical. It's probably just going to be that z-axis, but I'm going to give this a shot. So anyways, folks, this is pretty straightforward if you think about it. So I'm going to draw this for you. So think of it like this. Actually, no, let's not draw it that tilt. So think of it like this. This is going to be the x-axis, and this is going to be east and west, and this is going to be the y-axis. This is going to be the north side. And I don't know what the traditional way they label the east and west, or this is going to be the z-axis for sure, or what's up or down. So by east and west, it's going to be this. So let's keep reading this. So the object moves straight forward and then to the east, straight forward and then to the east around, forming in 1/4 of a circle of the radius that lies in the east and west plane. So let's just say that this is going to be the assembly where the object is, right at this origin, and it's going to move towards the east, and from east to west. So it's going to form the 1/4 of the circle, but it's not just going to move from east to west, folks. It's going to move east to west, forming this arc length of the circle. So I'm going to draw this in red. So it's going to go like this, something like this. And this radius in between here and here is going to be 4.80 centimeters. That's going to be the radius. So already, you can already make up the components of what this is going to be. In fact, we can do that, but let's do that later. And then the robot moves upward to the north through 1/4 of a. So notice that it says 1/4 for both of them, and of the radius 3.78 that lies in the north and south vertical plane. So let's draw that. So from east to west, and then from here to north. So it's going to move, if I can draw this, so it's going to look like this, something like that. So keep in mind, folks, that this is going to be the component. In fact, let me write this down. So, and this is going to be 3.70 radius. So this is going to be 3.70 centimeters. So that means that this is 3.70 centimeters. No, actually, yeah. My drawing kind of sucks, but anyway. So that's it, folks. That's all it is. It's just going to be moving. So let's actually put the vector here. So the overall vector displacement is going to be 4.80 in the i-hat direction. This is going to be centimeters, and this is going to be plus 3.70. No, that's right. In the centimeters in the j-hat direction. Now it's going to move up for 4.8 centimeters, and it's going to move an extra 3.70 centimeters. So I'm going to add that up. I'm going to use a calculator because I'm too lazy, or I don't want to make a mistake on these videos. But I didn't. So this is going to be 8.50 centimeters in the k-hat direction. This is the overall vector displacement from the origin to where this point is at. So remember that this is going to be from here to that displacement right there. That's going to be 3.50 centimeters, no, 4.80. It's going to go up that, and this is going to go up a little extra amount, 3.70 centimeters. And see, so so now it's going to ask for the magnitude. So let's find the magnitude. Since we already got all that out of the way, so the magnitude of this vector is going to be 10.44 centimeters. So that's going to be part A. Part B is going to ask for the angle of the total displacement mixed with the vertical. That's a little strange that they asked that. If you were to draw this, if you were to kind of draw this a bit, then you would realize that this is going to be the radius, and this is going to be the height here. So the radius is going to be the square root of 4.80 squared plus 3.70 squared centimeters, according to the, and the height here is going to be 8.50 centimeters. And the reason why I'm writing this down is so I can organize it, so I can take the 10 inverse of that value, so I can get that angle right there that they're asking. So so 10 inverse of that is 54. I'm going to take 90 minus that difference to get that vertical, from the vertical to the side. So I think this is the answer. I'm not sure. I'm going to pull the solution manual. The answer is going to be 35.5 degrees according to this. All right, folks, I'm done. This is going to be the solution manual that I'm going to pull for you guys, so you guys can so we can verify this. So, and let's see. So I'm not even going to read this, but it looks like the components, they have it differently. They apparently call up in the j-hat direction as opposed to the k-hat. Oh my fucking god, that's annoying. Okay, but the magnitude is the same, so it's okay. And it would be. It wouldn't matter what components you call which. So I did this a bit differently from the solution. This is why I don't like, them identifying, which they didn't in this problem, but in the other ones they usually tell you which direction, and I don't know what the tradition is, but it doesn't really matter really. But regardless, folks, whatever you call your I-hats, J-hats, and K-hats, I-hats, J-hats, and K-hats, these are the values, 10.40 centimeters, and the angle that they have is going to, with the vertical, is apparently the J is the vertical component. I don't know why they call y-axis. The tradition is so freaking weird. But regardless, folks, the angle is the same. So, and 10.4, I don't know where they got that from. I don't think they specified, but that might be the radius. It's probably going to be the square root of 4.8 plus that other component square. So anyways, folks, or maybe it's the other one. I don't know. But usually, I rarely look at the solution manual. Well, I mean, I'm only doing it for these ones, but if I do know the one, I usually don't. But anyways, folks, I don't know. I'm just ranting here. Anyways, folks, goodbye.